In this video, I'd like to introduce you to a Minesweeper puzzle. It's based on the old game Minesweeper, but it's been converted into a puzzle format. The rules are very simple. You have a grid, and the idea is to work out where the mines are placed in these blank squares in the grid. And each of these number squares tells you how many mines are adjacent to it, including diagonal. So, for example, this 2 means that of all these cells around it, 2 and only 2 of them are a mine. Okay, so let's start. Now, the easiest place obviously to start is if maybe you have a 0 number cell, because that means that none of these cells around it can be a mine. So we're marking those as not mines. Also, if we have a look at this 4 here, it only has 4 cells adjacent to it. So they must all be mines. Okay, and this number 2 here now has both of its mines adjacent, so that can't be a mine, and that can't be a mine. And this number 1 has got the mine adjacent, so that can't be a mine, that can't be a mine, that can't be a mine, or that one. Okay, now let's have a look at this number 2 up here. There are 3 possible cells for the 2 mines. But if you look, there's a 1 adjacent to it. So 2 of these 3 cells, these 2 cells cannot both be a mine because then they would invalidate that number 1. So only one of these 2 is a mine. So therefore the other one for that 2 has to be there. And if that's a mine, adjacent to 1, that can't be a mine, 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 that one, and that one also can't be a mine. Okay, so that means, if we look at this 2, there's 1 and there's only 1 free cell left, so that must be a mine. This 1 has got its mines, that can't be a mine, and that can't be a mine. Okay, we're making good progress so far. Now, let's have a look at this number 4 here. It's got 1, 2, 3, 4, 5, 6 cells that are possible for the 4 mines. But if we see that 1 there, we notice that these 3 are all adjacent to the 1. So only one of these 3 cells there can be a mine. So therefore, for that 4, the other 3 have to be the remaining ones. So we know those are mines. Similarly, we know then that only one of these can be the 4th mine. So for this number 1, it has to be one of those 3 to be a mine. So we know that that can't be a mine, that can't be a mine, and that can't be a mine adjacent to that 1. Because either this one, or that one must be a mine. Okay. Now it gets a little bit more tricky. Let's have a look at this number 4 here. It's got 2 mines already, and 1, 2, 3 possibles for the other 2. So let's assume, if we assumed that that one's not the mine, and those 2 are the mine, what happens then is that this 2 has already got the 2 next to it, which means that that can't be a mine, and that can't be a mine. So for this 4, 1, 2, 3, it's impossible to be satisfied. So we know that this original assumption there was incorrect. So let's just undo that. We know then that this one has to be a mine. Okay, let's have a look at this 2. If that then was a mine, those 2 wouldn't be a mine, and then we know that we can't satisfy that 4. So that one cannot be a mine. And if that can't be a mine, for this number 4 we have 3, we have only 1 left to be a mine. So that one has to be a mine. Okay, which means that this one, that one can't be a mine, and that one can't be a mine. Okay, so for this 4 here, we have 1, 2, 3, and the 5, 3 left for 2 remaining mines. Only one of these can be a mine, because we already have one next to that 2, so only one of these can be a mine. Therefore, that one has to be a mine. And now we have 2 mines adjacent to that 2, so we know that that can't be a mine, and that can't be a mine, which means that one has to be a mine, and that 4 is now satisfied, that 4 is now satisfied, the 1 has been satisfied, so that can't be a mine, that can't be a mine. Over here for this one, there's only one place left for a mine, and there's 3 can't be a mine. So there we have it.